Okay, hello my form threes. How are you all doing? Okay, I hope everyone is well. Okay, welcome back to our class for May week 4. Okay. There will not be any videos next week because due to the Hari Raya holiday. Okay. So this will be our lesson right before the holidays. Alright, so what are we going to talk about today? Today we are going to learn about AC and DC. Okay, last week we learned about generation of electricity. This week we are going to learn about type of AC current. Okay, I think you learned this in Form 2 already. What is current? Okay, so current is divided into two types. Okay, you have DC, direct current, and AC, alternating current. Okay, as the name says, very simple. Direct means it is coming in one way. Okay, for example, now you have a battery. You connect this to a light bulb. Okay, so current only goes from positive to negative. That is DC. Okay, AC is more funny. AC you don't get from battery. Okay, AC looks like this. Okay, the symbol looks like this. Okay, and then okay, you don't use the AC anyway. Okay, AC you use it at home. Okay, the electricity coming into your house, okay, which is your wall plug and everything, your aircon and everything, it uses AC. Okay, so why do we use AC? We will talk about this soon. Okay, so how do we know what is AC and DC? We use something called a CRO. Okay, a cathode ray oscilloscope. Okay, this is basically this thing. Okay, not whether sure you've seen this before. You have a screen in the middle. Okay, and then when you connect this to either AC or DC, you can see the graph moving. Something like the hospital, your heartbeat thing. Okay, the beep 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 thing. Okay, so something like that. Okay, so it's an electronic device to show differences in the shape of graph, direction of current, and voltage change for AC and DC. All right, so all this, what is Y naught, Y shift, Y X shift? You don't need to know. Okay, so you only need to know the shape of the graph. How does AC and DC look like? That's all. Okay, let's look at AC and DC difference. Okay, DC it flows in one direction only. Okay, but AC is constantly reversing direction. It means AC is moving like in, like that. Okay, so DC is only like that. Battery is only from positive to negative. For AC, there's no positive and negative. Both can be it. Okay, so let's look at the graph. Okay, let's look at similarities first. Okay, they both produce heat. Okay, not so important, can be measured. Okay, normally they won't ask similarities. Okay, let's look at the difference. Okay, since DC is only one direction, the graph looks like this, one flat line. Okay, let's say my battery is 5 volt. It will stay 5 volt until the thing dies. Okay, but AC is different. If I am 5 volt AC, okay, my volt will be 5, negative 5, 5, negative 5, 5, negative 5. That's why you see the graph is like up, down, up, down, up, down, up, down, because it's 5, negative 5, 5, negative 5. So AC, DC. Okay, simple. Okay, so difference, flow, one is one direction, this is alternating. Okay, magnetic effect, okay, this is also related to just now. Okay, since this is only DC is only one direction, okay, it is fixed, means one side is north, one side is south. But since AC is changing, so the magnetic is also changing. Okay, and then voltage transformation. Okay, what is this? We'll talk about this later. Okay, ability to flow through capacitors, cannot and can. Okay, what is capacitor? Capacitor basically is small power bank lah. Okay, when you see an electric circuit board, you see the black color thing on it. That is capacitor. That is to store charge. Okay, basically your power bank is full of capacitors lah. Okay, to store charge. Okay, and then source. Okay, mostly DC you get it from very small voltage source like battery. Okay, solar cell. Solar cell is very small. Okay, direct current generator, dynamo. Okay, and you use it in small appliances like torchlight, calculator, toy car. But AC is much stronger, like AC generator. You use it in hair dryer, air conditioner. That's why our house uses all this. That's why our house needs AC. Okay, DC is not very stable. Okay, so to generate electricity, okay, all this you can read yourself. Okay, absorb solar energy. Okay, change to radio wave. Okay, wireless charging. Okay, not so important. Okay, this is our main point today, which is transformer. Okay, so What is a transformer? Not that movie, okay? Not that shitty robot movie, okay? Let's face it, Transformer is a very terrible movie. Okay, so what is transformer? Okay, when I need to change the voltage of something, okay, think about this. Now, do you know how much voltage our country use from the wall? Okay, our wall uses 240 volt. Okay, now you need to charge your phone. Okay, your phone only needs 5. Or if you use a Samsung quick charging, it's only 9. Here's the problem. How do you put 240 into it? Can you really direct 240 into it? Oh, sir, I hope I can put 240, it can charge faster. No, it doesn't work this way. Your phone is gonna explode. Okay? So your wall outlet is enough to kill you. It's strong enough to kill you. Okay? So to convert this 240 to 5, we use something called transformer. Okay, transformer. Okay, so just now, remember, we talked about DC and AC. Okay, transformer only works in AC. This is why our wall and the whole country uses AC, because if we use DC, we cannot use transformer. Okay, that's why we use AC. Okay, so how does a transformer look like? Basically, it's not as interesting as the robot, of course. Okay, it's basically a squarish thing. Okay, so you have a square. This is actually a piece of iron, a square-shaped iron. Okay, something like a iron, like a window. Okay, and then one side you have wire, the other side you also have wire. Basically, that's transformer. Okay, so a transformer. Transformer is a device for changing the voltage of an alternating current. Okay, a simple transformer is made of, okay, what is it made of? Very important, please highlight here, laminated soft iron core. Okay, laminated soft iron core. Okay, what does it mean by soft iron? Soft iron means it's made from pure iron. Okay, something like that. Okay, and then what is laminated? Okay, instead of one big piece of iron, now I'm using small pieces of iron, and then I use insulator in between. Something like a sandwich. Can you see this is like a sandwich? Okay, so iron, then maybe I put insulator like wood, iron, wood, iron, wood, iron, wood, instead of one big piece of iron. Okay, why? Because this is more efficient. I don't waste that much of energy as heat. Okay, I hope you can understand this. Okay, so the main point here is I use laminate soft iron core. Alright, so wrapped by 2 insulated coil, primary coil and secondary coil. Okay, so what is primary coil and secondary coil? The one that you are giving it, you are putting it in, we call it input lah. Okay, it's the primary. Okay, the one that is coming out, the output, the one I want to get, okay, is secondary. Okay, so that's the job of your charger. Your wall gives it, when you plug it to the wall, the primary is giving 240. So the secondary, the coming out, is giving you 5. That's the output to your phone. Okay, so now you have 2 types of transformer. Very simple. You have step up and step down. Okay, what is step up? Step up is to increase my voltage lah. Step down is to decrease your voltage. So your charger uses a step down. Okay, so do you use step up? Not at your home. Normally this is at your substation, your TNB substation. Okay, we will learn this next week. Okay, so can you see step up is like the primary coil has very little coiling, like 3 rounds, but secondary has many coilings. Okay, so can you see I'm increasing my voltage? The coiling means voltage. More coiling means more voltage. So my secondary has more, okay, primary has less. So that's why I'm stepping up the voltage. So the symbol, okay, if you must know, the symbol looks like this. So primary voltage or the input is lower than secondary. Okay, you can put it here. VP is less than VS. Okay, secondary is larger because I'm stepping up. Okay, so it's already written here like input is less than output. Okay, but for step down, it's the other way around. Okay, sorry. Yes, that's the way. Okay, so secondary is less than primary. So can you see the coiling here is less? I'm decreasing my voltage. This is more. I'm decreasing it. So step down. Okay, so number of turns. Okay, so number of turns. So like I said, more turns means more voltage. So just now, secondary is more than primary ma, which means secondary, the coiling is more than the primary lah. Okay, the secondary has more turning. So same goes to your step down. So secondary has less than primary. Okay, so more coiling means more voltage. Okay, very simple. So okay, where do we use step up? Okay, microwave oven. Okay, we use this, okay, because microwave uses a lot of heat energy to heat food. Washing machine, I'm not too sure. Okay, refrigerator, television. Okay, but mostly we use step down at our homes. Okay, like phone charger, laptop charger, tablet charger. Okay, that's why I said please don't cheap out on the charger. Please don't use some China unknown brand cheap charger. You are gonna kill yourself. Okay, why? Because the transformer can get short circuit, and then the thing will get heat up, and then when it explodes in your face, that's how you die. Okay, same goes to battery. Please use some high quality battery. Okay, so okay, there you go, common sense. All right, so let's look at the transformer equation. Okay, so we can calculate transformer by this formula. Okay, Vp over Vs equals to Np over Ns. Okay, so Vp you already know lah, that's the primary voltage. Ns is secondary voltage. Np is primary number of coil. Ns is secondary number of coil. Okay, so let's try this question. Okay, the primary and secondary coil of a transformer each have 600 and 1800 number of turns. Okay, please label first. I like to label my stuff so that I don't get confused. So 600 is NP, that's the number of turn of primary. 1008 is NS, number of turn of secondary. Okay, so the primary coil is connected to 230 volt AC. So this is my VP. I'm going in. What is the output of the transformer? So now I want to find VS. Okay, so we know the formula Vp over Vs equals to Np over Ns. We just throw everything in. So my Vp is 230. Okay, Vs I don't know, just write by Vs. Np is 600. Ns is 1008. Okay, so this is basic maths lah, guys. So this is 1, this is 3. So throw here, throw there. Vs you should get 690. Okay, volt. So I'm stepping up 230 to 690. Okay, so let's do another one. Okay, a transformer has a reduced voltage, has to reduce the voltage of 240 to 60. So this is my Vp going in, this is my Vs coming out. Okay, if number of turns of primary is 500, so this is Np. Calculate number of turns of secondary coil, means they want the Ns. Okay, so again, sub in the formula, 240 over 60 equals to 500 over don't know. Okay, so throw here, throw there, and as you should get 30,000 divided by 240. So you should get, let me do a quick one. Okay, 30,000. Wow, this is so big. You divide by 240. Okay, so you get 125. Okay, 125 turns. Okay, because the N is the number of turns. Okay, so that's it for today. Okay, we will learn about how TNB gives you your electricity next week. Okay, so let's go into the exercise. Okay, oh, we talked about this last week. Okay, I hope you have done this. Okay, number 10. What is meant by direct current? Okay, current that moves in one direction only. Okay, so alternate current is current that moves in changing direction. Okay, so what is P? P is my DC lah. Please write direct current. I'm just writing the short form for you. Q is AC. Give the electric source that gives current P and Q. So this is battery. Okay, Q is AC generator. Okay, or you can say AC. You have DC generator and AC generator. Okay, so give two difference between P and Q. Okay, so P. So many lah. This one what are the difference? Okay, so you just write it yourself. Okay, two differences. Okay, one direction, many direction. Okay, and the magnet is one is changing, one is not changing. Okay, write it yourself. Okay, so there are two types of electric current which are direct and alternating. So one direction, this is AC, DC, sorry. So, oh, this shows like up and down, this is AC. Okay, so who produces DC? Solar and battery. Okay, wind creates AC. Okay, this is why we don't use solar that much, because solar gives DC which we don't want. We want AC. Okay, so diagram below shows the device used to differentiate. Okay, this is your CRO. So AC, how do you draw? Okay, you can draw up, down. Okay, make sure you make this as your middle point. I don't simply draw. Name the device shown. This is a cathode ray oscilloscope. Okay, CRO. Okay, what are the properties of electric current studied using this? Okay, what are the properties? Okay, so it means they want to know the AC. Okay, so changing direction. Okay, changing magnetic field. Okay, they want the current I'm studying right now, which is AC. Okay, so name the type of, okay, so now you see why is it so weird, so why is this like that? Okay, because I didn't switch on my x-axis. If I switch it on, it will look like this, up down up down up down. This is still up down, but now I make it in 1D or 1D 2D. Okay, switch off my x-axis. Okay, so this is still an AC. It's just that I switch off I'm changing the setting on the CRO. Okay, so this is AC. So the one line is DC lah. Okay, so transformer function only using AC. You can only use transformer for AC. DC doesn't work. In a step down transformer, number of turns of primary coil is more. Okay, primary has more than secondary, that's why the power coming out is small. Okay, because it's a step down. Okay, so from 25 to 250, I use step up. Okay, what is fixed in the radio? We use a step down. Okay, because radio is very small. Okay, so what is this? This is a soft iron core. Okay, oh sorry, laminated soft iron core. Okay, so this is primary coil. This is secondary coil. Okay, what is a transformer? A device, okay, used to change voltage of an AC source. Okay, must be AC, no DC. Okay, one example which you step up, okay, your, what was it just now? Your microwave oven. Okay, step down your phone charger. Okay, so why is laminated iron core used in transformer? To increase, okay, efficiency. So that it's more efficient, not much of wastage. Okay, it doesn't waste electricity. So if the number of turns in the primary coil is 100, okay, so this is my NP. Number of turns in secondary coil is 20, so this is NS. Calculate the secondary voltage. So now I want VS. If the primary voltage is 10, so this is my VP. So VP VS equals to NP NS. So VP is 10, VS don't know, NP is 100, and then it's 10. So VS is 10. Wait, 1, sorry. Okay, 1 volt. Okay, ayo, so simple lah. Oh, sorry, 20. Oh, I fill in the wrong one. Oh, sorry, this is 20. Okay, so this is 1, this is 5, so we should get 50 volt. Okay, so two types of transformer, again, same thing. This is step up because I'm becoming more. This is becoming less, this is step down. Okay, compare P and Q. So how do you compare it? Okay, so you can say for P, the secondary voltage is more than primary, but for Q, secondary is less than primary. Okay, so that's 1 mark already. And then you can talk about the number of turns. Okay, so same thing for P, secondary has more turns than primary, but for Q, secondary is less than primary. Okay, so what else? Oh, compare. You can even say the similarities. Okay, they both use soft iron core. Okay, or you can say both uses AC. Okay, they must use AC. Okay, so calculate. Oh, they even draw it for you. So this is 2 and 125. Okay, so this is my VP, NP. This is NS. So VS I don't know. Okay, so I just put it in. NP is 2 over 125 equals to 240 over VS. So my VS is 240 times 125 divided by 2. Okay, calculate yourself. Okay, what is the ratio? Okay, ratio of secondary coil, okay, NS to NP. Okay, write it yourself. Okay, I know that my N. Oh, you don't even need to calculate this. Okay, NS is 125, NP is 2. Okay, you just leave it like that. Okay, because we need whole number for ratio. Okay, so apparatus to study the function of transformer. Okay, this is a step down. Okay, because the turns is becoming less. Label the primary coil and secondary coil. So this is my primary. Okay, this is my secondary. Okay, predict the value of output if input is 10, supplied is 10. Okay, justify your prediction. So they didn't give turns or how? Count yourself lah. So how many turns here? 1, 2, 3, 4, 5. How many here? 1, 2, 3. This is 3. Okay, so predict, you just calculate. Okay, so NP is 5, NS is 3, VP is 10, VS don't know. So VS I should get 30 divided by 5, you get 6. Okay, 6 volt. Okay, justify your prediction. How do you know? Okay, because the ratio of NP to NS is, okay, you use ratio to explain, is 5 to 3. Okay, so 5 to 3, that's why when it's 10, then it's 6. Okay, so the student group wants to obtain a larger output voltage. What modification should be done? So how do you make the output larger? Okay, so you can increase number of coil, number of output, so secondary coil. Okay, so the secondary there you turn more lah. Okay, or you can say increase input voltage. Okay, or primary voltage. Okay, so a student set up the apparatus using different method, so they are using this way. Okay, does this work? No. The group finds that the voltmeter does not record any output reading. Explain why. So can you see the source? I'm using battery. Battery is DC. DC does not work. Okay, explain. Okay, the primary source is using direct current. Okay, so we can say transformer only functions with AC. Okay, so C you calculate yourself lah. Okay, the rest I'll leave it up to you to do. Okay, they're all pretty much repetitive question. Okay, so that's it for today. Thank you for paying attention. I hope you learned something new today right before you go and rest. Okay, you're resting now lah, isn't it? Okay, so next week, I hope that, yeah, you can play and enjoy yourself, no problem. But I would like you, if you can, to spend a bit time on your studies. I'm not asking for much. I would only ask you to spend like 1 or 2 hours the whole week on science. Okay, 7 days, you pick 1 day, you use that day 1 hour and refresh on science. What have you learned so far? Okay, I know we are doing online lesson. That doesn't mean you can slow down. Okay, I know PT3 is cancelled, but it still depends on your final year exam to determine what stream you're entering next year. All right, so I hope you are not slacking because of this lockdown. I hope you continue to learn. All right, so that's all I have to say. Okay, so thank you again, and I will see you again next week. Enjoy your holiday. Okay, I'll see you again the following week. Okay, so long and bye bye.